So today I'm going to be going over the definite integral. And what we use this for is to find areas under curves. So if we look at this shaded region right here, there's no way to solve for it geometrically. So the only way to solve for it would be to use this process of the definite integral. So let's just say that we were given this function and we were asked to find the area under the curve. So before, we would have had to add up some rectangles to get an estimate. So something like this. But as you can see, the problem with this is that it doesn't give an exact answer. We can get really close by adding up more rectangles, but it's still not going to give an exact answer. So the way around this and what we're going to do with the process is we're actually going to add up an infinite amount of rectangles. So for this process, there's actually 6 steps, and right now it's not really necessary to know the reasoning behind every single step, but there's actually a couple things that you should know, mainly that A and B in step 1 are the endpoints of the area that we're trying to find, and that for step 4, there are a couple of summation formulas that you should memorize as well. So let's say we're given the function negative x squared plus 8, and we're trying to find the area under the curve from 0 to 2. So step 1 would be trying to find change in x. So that would be b minus a over n. So that would be 2 minus 0 over n, which would be 2 over n. Step 2 would be find c sub I, which is a plus the change in x times I. So it would be 0 plus 2 over n times I, will just be 2i over n. 3 would be to plug it back into the function, so it would be negative 2i over n squared plus 8, which is equal to negative 4i squared over n squared plus 8. So what we want to do from here is to take the summation of what we got in answer 3. So what that would look like is this. From here, we want to split the summation into 2 because we can't take the summation of the whole thing. So looking back at our summation formulas, we recognize the I squared right here, and we recognize that this is a constant, but we didn't get rid of this negative 4 over n squared. So what we can actually do with that is we can move it out front, and what that would look like is this. Now we can just use our summation formulas to evaluate and simplify. So after simplifying all down, we get this. And so step 5 would be multiply whatever this is by change in x, which would be 2 over n. So if we multiply that by 2 over n, we get 40 n squared minus 12n minus 4, all over 3n squared. And the last step is just take the limit as this goes to infinity. And by doing that, we can just look at the coefficients, which is 40 and 3. So the answer would be 40 over 3 units squared. So as you can tell, this is a really long process, and this is how it's going to go for most of the definite integral problems. So that means you'll want to be extra careful around the entire thing, but especially around step 4, as there's a lot of simplification involved, as well as in step 5, where a lot of people just forget to multiply by changing x in the end. So let's just look at another example where it's asking us to find the area under the curve from 1 to 4 of x squared minus 4. And you notice how it's written differently this time, but it's just another way to write it, where the top number would be b and the bottom number would be a. So again, let's start off by finding change in x. And then we'll find c sub I. And then we'll plug it back into the function. Which simplifies down to negative 3 plus 6i over n plus 9i squared over n squared. And then we can take the summation of this entire thing, And then we can separate the summations into its parts. And I'm just going to go ahead and say that this simplifies down to 6n squared plus 12n plus 3 all over 2n to save some time. And step 5 would be to multiply whatever this is by changing x, which is 3 over n. And that would give us 18n squared plus 36n plus 9 all over 2n squared. And the last step would be to take the limit as this goes to infinity, which would be 18 over 2, which is equal to 9. So overall, although this process may seem long and kind of pointless after knowing about the shortcut, it's really helpful in showing us how and why we do this to find areas under curves. So overall, just some final tips is to memorize the process and be familiar with the steps. To be careful when simplifying because there's a lot of steps and a lot of places to go wrong. And lastly is to memorize the summation formulas because you won't be able to solve the integral without them.